Right, so let's have a look at these problems related to binomial distribution. So in the last video we introduced binomial and we talked about the BPD function, so we're going to stick with that for the moment. Now just bear in mind what I'm going to show you now, there is another approach to it which we'll learn in future videos as we move through the booklet, but I just want to stick with the BPD function just to get familiar with that. You'll understand what we mean as we go forward. Okay, so school estimates. What I will do here is I will do the two examples down here. I'll then let you pause the video, have a go at the now you tries, and then I'll do those examples. Okay, so a school estimates that the probability that a student passes an exam is 0.9. 5 students are sitting the exam. So we're going to assume this is binomially distributed. I think a question in an exam would state that, but we will assume it. So I am going to write my binomial distribution. Always make sure that you do this. Don't do the calculations without writing the distribution down. So I'm going to stick with x. That's the most common convention. Always use a capital letter. Is distributed with a binomial distribution, and there are 5 trials. So there's 5 students that we're checking for. The probability that they pass is 0.9. So that gives us plenty of information to be able to start doing any calculations that we want to know. I want to know the probability that fewer than 2 students pass. Okay, so let's just think about the situation here. So we have 5 students taking the exam. So the potential outcomes here are that no people can pass the exam, they all fail. 1 person passes the exam, 2 people, 3 people, 4 people, or all 5 of them pass the exam. Nothing else can happen. Those are the only 6 outcomes. So what we are checking for here, I want to know the probability that fewer than 2 students pass. So I want to know the probability of either of those 2 things happening, that there's no people pass or 1 person passes. So what I'm going to write down is that the probability of x being less than 2 is equal to the probability of x being equal to 0 plus the probability of x being equal to 1. Okay, I'm going to do these on the calculator rather than using the formula. Okay, so let's go to my statistics mode, into distribution, binomial, and I'm going to use BPD. So I'm only using I'm going to come on to the BCD later, but the BPD is where the value is equal to something. That's when we use BPD. So I'm going to do BPD. I've done this earlier, so I've kind of got some of the values in. So the probability is 0.9, the number of trials is 5, and I want to check the probability of it being equal to 0. So that's how I want it set up. Sorry, a bit of light shining on it. There we go. So what I've got is 1 times 10 to the power of minus 5. So that is 0.00001, I believe. I then want to work out the probability of x being equal to 1. So all I need to change there is the x value. So the number of trials and the probability are the same. And I've got 4.5 times 10 to the power of minus 4. So I've got 0.00045. And if I type those into a calculator and add them up, I get 0.00046. So that is my probability of less than 2 students passing. It is a very, very unlikely scenario. Okay, right, so let's move on to this next one here. I'm going to go down the left. Now this is a good example of where you need to be quite careful on these sorts of things and read questions really carefully. So according to recent data, the probability that low-cost airline Ryanair loses a passenger's luggage is 0.05. We fly with Ryanair 6 times. And the question is asking me, find the probability that I arrive with my luggage on exactly 5 flights. Now this question, can you see this question says that the probability that I arrive with my luggage, I'm given the probability that my luggage is lost. So on the basis that I will either lose my luggage or not lose my luggage, the distribution is going to be this. On the basis that I want to check for when I do not lose my luggage, that I arrive with my luggage. So actually I'm going to use 0.95, which is 1 minus 0.05. So I think that's something to be very, very sort of careful about, and interpreting the question and understanding it is very key. Probability that I arrive with my luggage on exactly 5 flights, so I'm looking for the probability of x being equal to 5. I've now got nice and straightforward. I've got everything I need to just whack it in the calculator. So I'm going to do number of trials 6, 0.95, and my x is 5. So I have the probability of that happening is 0.232 to 3 sig fig. Okay, right, so what I'd like you to do now is just pause the video, try the Now You Tries. When you restart the video, I will go through these. Okay, so pause now. Okay, so hopefully you've had a go at those. Let's have a look at this one. So now I'm on to the school one first of all. So the school estimates that the probability that a student passes an exam is 0.95 students are sitting the exam. This time I want the probability that 4 or fewer students pass. So I've got the same distribution, haven't I? That's no different there from the previous question. And I want to know the probability that 4 or fewer students pass. So I'm after the probability of x being less than or equal to 4. So let's just think about that. So I could do the probability of x being equal to 0, plus the probability of x being equal to 1, plus the probability of x being equal to 2, plus the probability of x being equal to 3, plus the probability of x being equal to 4. I could add them up, get a probability. That's fine and that would work, but that seems a little bit long-winded. So bear in mind that all probabilities add up to 1. I think we have a little quicker way of doing this. So what I'm going to do on this one is I know that the probability of that happening plus that, plus that, plus that, plus that, plus that is all going to add up to 1. So what I am going to say is the probability of these 4 happening is 1 minus the probability of that happening. So 1 minus the probability of x being equal to 5. So that should make my life a little bit easier. So let's put that in the calculator. So I've got my number of trials is 5, I've got my probability is 0.9, and I'm after the probability of x being equal to 5. So that's set right. Plus that equals. So I've got 1 minus 0.5905. I go to my normal calculator part, 1 minus 0.5905, and that gives me 0.4095. Okay. Fine. Okay. So let's go on to this next one with the Ryanair. So the probability that I arrive with my luggage on more than 4 flights. So again, arriving with my luggage, the probability is 0.95, and I'm after the probability that I arrive with on more than 4 flights. So let's just think that one through. So I've got 0.1, 2, 3, 4. Those are the 7 things that can happen I'm flying 6 times, so I can arrive with my luggage anytime well between 0 and 6. I'm looking for more than 4 flights. So I'm after the probability of that happening plus the probability of that happening. So actually what I will do here is this. Into my stats mode, distribution binomial BPD. I'm after number of trials is 6, probability of arriving with my luggage is 0.95, probability of 5, so that is 0.2321, plus I'll do those to 4 significant figures for these, and also the probability of x being equal to 6 is 0.7351, and I'm going to add those up on my calculator. 0.2321 plus 0.7351, so that is equal to 0.9675. Okay, and that's how we go about those.